All right, good morning, students. Please turn in your books to page 380. We are going to complete lesson 10.1. There are several problems we're going to work together, and then you can see on the board in Miss Williams' room the homework. I believe it is on page 390 or just after page 390. I want to talk about the 360 degrees for just a moment. 360 degrees in a circle. You can see a side note about this on page 380. So one of the things that you want to understand about this 360 degrees is that there's no fundamental reason that 360 itself is at all special. So I'm going to draw a circle here, hopefully a good circle. Let's see. Yeah, that's not too bad. In this circle, we have that total of 360 degrees. And so you're probably familiar with what we call a right angle or a 90-degree angle, where each fourth of this circle makes up a fourth of those 360 degrees. But let's say I decided to invent something called Ricchuigrees. And I'm going to say instead that there are 1,000 Ricchuigrees in a circle. Could we still say something about that right angle? You should be thinking to yourself, well, yes, we could. That right angle still makes up a fourth of the circle, but now rather than call that 90 degrees, we would call that 250 Ricchuigrees. And of course, going around the circle, there'd be another 250, another 250, another 250. All that's important is to make sure that we add up to 1,000. What this tells us is that there's nothing special about that number 360. What's actually special about angle measurements is they're telling us something about the portion of a circle. And in fact, a little bit later in your mathematical careers, you will define angles in a new way. You'll define them with something called radians, which are entirely about the lengths along the edge of a circle that a given angle cuts out. For now, though, of course, we're not going to work in radians or Ricchuigrees for that matter. We're just going to stick to regular old degrees. And the things you want to remember about degrees is that a quarter circle, or a right angle, is indeed a 90-degree angle. A straight angle, that would be a line going straight across. You can think of it as the diameter of the circle, but any line will do, makes up 180 degrees. And then, of course, the full circle itself would be 360 degrees. So those are three important angle measures you always want to be aware of. Let's go ahead and jump into the problems. On page 381, 10.1, I'll let you take on for yourself because I do not have a protractor here, but it should be relatively easy to measure those angles as listed using a protractor. If you're given no other information, as is the case in problem 10.1, really, you just need to actually measure it the same way we would measure with a ruler or a yardstick or anything else. Problem 10.2, though, is a little interesting. We have a clock. So again, let's imagine our circular clock. Is that going to be a good enough circle? Yeah, that's pretty good. And of course, the clock has 12 at the top and 6 at the bottom and all the other familiar things that you know about a clock. So we have 12, 3, 6, 9. And then all the other numbers from there, 1, 2, 4, 5, 7, 8, 10, 11. Problem 10.2 asks us to figure out the angle measure when it's 5 p.m. Well, take a moment, sketch out in your own notebook or on your own piece of paper, what does a clock look like at 5 p.m.? Of course, we're going to begin from the center here, and then we're going to go ahead and draw the hour arm to 5 p.m. So that is the shorter arm, 5 p.m. And then the longer arm, the minute hand, at exactly 5 p.m. is going to go to exactly 12 o'clock. And so basically what we want to figure out right here is this angle measure from 12 to the center and then back out to 5. What is that angle measure? There are a couple different ways we could approach this. Here's what I'm going to suggest. We know that the whole circle has a total of 360 degrees. So imagine slicing this into a bunch of different pieces of pizza, basically. How many slices of pizza would there be if we divide up the clock the way that we would divide up a pizza? You can probably tell, unsurprisingly, I mean, it is a clock, right? There are 12 pieces of pizza. And so we can take that total of 360 degrees and divide it into 12 parts, And that means each one of these slices has a total of 30 degrees. For this distance that they were interested in, 5 p.m., or rather this angle measure at 5 p.m., we can see that that's going to be 5 full slices. And so the answer to that question would be 5 times 30 degrees equals 150 degrees. And so I would put a nice little box around that. That's my answer for 10.2, excuse me, 10.2a. Right, 150 degrees. Now 10.2b gets a little bit more complicated. It says, okay, well, what's the measure of the smaller angle between the hour hand and the minute hand about 24 minutes later at 5:24 p.m.? So let's think about what has changed by the time that we get to 5:24 p.m. Again, I'm going to go ahead and draw a clock, 12 to 3. Although this time I'm not, I wanted that to be different. Let's see if we can get a good clock here. Yeah, that's a lot better. Okay, so we still have 12, but of course this time the minute hand isn't at 12 anymore. We need to figure out where would the minute hand be at 5:24. And so let's think about just the minute hand for a second. The minute hand makes a full 360 degree rotation in an hour. That is, the minute hand travels 360 degrees per 1 hour. But of course, right now, we want to know about 5:24 p.m., which isn't a full hour. It's only 24 minutes later. So we need to convert this into a number of degrees per minute instead. And so we're going to use basically a conversion factor. And we're going to see that the minute hand travels 6 degrees per minute. And so to get to 5:24, we will have gone 24 times 6 degrees equals 144. And so that measure is going to be something like, if this, of course, is where we're starting, then our minute hand will have gone almost this 150 degrees, but not quite, right? We need to go 144 degrees, which is going to put us somewhere between 4 and 5 o'clock. And I'm just going to mark this as 144. So here would be 4, and here would be 5. And that's 144 degrees. And that's the minute hand. Now let's think about where the hour hand is. The hour hand and the minute hand don't travel at the same rate, because the hour hand only completes one of these 30-degree one of these 30-degree trips every hour. So the hour hand only travels 30 degrees per hour. But again, what we're interested in this case is some number of minutes, and so again, we're going to convert this to minutes, or degrees per minute, and you can see we end up with 30 over 6, which ends up being the same thing as 1/2 degree per minute. And so the hour hand, which you'll remember had started at 5 o'clock, has now traveled 24 minutes times 1/2, which is going to be 12 degrees. And so it started at 150. I'm actually going to, I should have put that in as a dotted line. That's what I wanted to do. Okay, so it started here at 150 degrees, but then, like we said, 24 times 1/2 equals 12. It traveled another 12 degrees, and you can see it's almost halfway, because of course it's almost 5:30. And so that total distance, if we go all the way around in red, should be the 150 degrees that we started at for 5 p.m. That's what this over here was telling us. But plus those additional 12 degrees, so that's going to be 162 degrees. Finally, to find the actual angle that we're interested in, which would be this angle right here, between where the minute hand is now and where the hour hand is now, all we have to do is subtract. Very good. We're going to do 162 minus 144, and that's going to tell us that the angle now between these two hands must be 18 degrees. And I do want to check this one. I don't know that I'm super confident in my work here. But as we look ahead to the solutions, which starts page 383, and then the 10.2 solution, page 384. No, my goodness, that 10.1 problem takes a while. Page 386, you can see part B does indeed give us the 18-degree solution. It also gives us what they call a bogus solution. You can read that on your own. You want to be careful about thinking about where the minute and hour hands are with respect to each other. You can figure out pretty easily where the minute hand is with just some simple proportional reasoning, but you want to keep in mind that, of course, the hour hand is moving at the same time. And so that's why we figured out both the minute hand rate, 6 degrees per minute, and the hour hand rate, 1/2 degree per minute. But there you have it. That's 10.2. Let's go back to page 382, and let's look at 10.3. So 10.3, we have this information. We have several angles. We've got a 64-degree angle, looks something like that, an 80-degree angle, a 143-degree angle, and then we have our unknown, x. And what we want to do is figure out the value of x. Now, of course, one thing you might think is, well, why don't we just use a protractor like we did earlier? And in the book, you might be able to do that. It looks like that's pretty much drawn to scale. But you can tell my diagram is a little bit different. That's probably not really an 80-degree angle, because, of course, an 80-degree angle should be almost a right angle. This probably is not really a 64-degree angle, as I was just sketching it out. So when you do your own sketches, you wouldn't necessarily be able to use a protractor to figure out what's going on. So what we have to do instead is use a fundamental property of angle measures. Recall we said there were kind of three key angle measures you always want to keep in mind. Of course, there is the right angle, a fourth of a circle. There is the straight angle, which is 180 degrees. And then there is also the full circle itself, and that's what we're going to use in this case. These four angles together, you can think of them as if they were at the center of a circle. And we know the total there has to be 360 degrees. And so we can actually set up a nice little equation right now. We could say x plus 64 plus 80 plus 143 equals 360. And we can now add together our like terms, the numbers here. 64 plus 80 is 144, and 144 plus 143 is 287. So x plus 287 equals 360. And then, of course, this is a simple single-step equation that we can solve by subtracting 287 on each side. 360 minus 287 is 53, I believe, if I've done that correctly. And so we could say that the angle measure for this unknown angle x is 53 degrees, based on the fact that we know the total has to be 360 degrees. So there you have it. That's how I would do 10.3. All right, moving right along these pages, these problems for page 382. Problem 10.4. In the figure below, angle AOB is a straight line. What is the measure of angle AOB? Well, based on, again, those three angles that I said you want to be familiar with, this should be a very simple problem. If I draw it out real quick, though, just to think about it a little bit more, I've got A, I've got my central point O, I've got B. Imagine that we added in that third side. You might be wondering, I didn't talk about this earlier, you might be wondering, why is the straight angle 180 degrees? If we added in a perfectly perpendicular side, it would obviously make a right angle here on the right, and that would be 90 degrees. It would also make a right angle on the left, and that would be 90 degrees. And so, of course, my total angle AOB is just going to be the sum 90 plus 90 equals 180. And so that's why we can say that the straight angle has a measure of 180 degrees. And so that would be the answer to problem 10.4. Problem 10.5, in the figure, lines PQ and RS meet at point O. So let me go ahead and draw that out. So that would be PQ, and this would be RS, and we'll go ahead and label it similarly to your book, RS, P, and Q, and there at the center they meet at O. If angle SOP, so let's see, SOP, that's how we draw angles. The middle letter is always the vertex of the angle. If that's a 37-degree angle, what is the measure of POR? So this other side of the angle. Well, take a moment. I want you to work on this one in your notebooks on your own. I bet you can figure this out. So I'm just going to pause here for maybe 30 seconds. All right, if you figured out that the answer was 143, you are correct. Well done. You should be able to see here pretty easily that RS, or ROS, if you want to call it that way, is a straight angle, is that 180-degree angle. So these are what we call supplements. Angle ROP and angle POS are supplementary angles. Supplementary angles are those that have a sum of 180 degrees. And obviously, being that these two angles make up the straight angle together, they have that sum of 180 degrees. And so we can simply say 180 minus 37 equals 143. And so that's the measure that we're interested in, 143 degrees for angle ROP. The way that we write this, so that you know in the future, we don't say angle ROP equals 143. The angle is an object, not a number. What we say is that the measure of angle ROP, or rather POR, the way they put it in the book, is equal to 143 degrees. And so this little M at the front tells us, yeah, we're looking for a quantity. We want to know how large the angle is, the same way we want to know how long a field is in feet or yards or some other kind of measure. And so that's what lets us have a number back as an answer. All right, I'm going to have you do 10.6 and 10.7 on your own. Of course, the explanations are in the book, so after you work 10.6 and 10.7, you can take a look at those explanations. I want to try to finish up with 10.8. So let's go ahead and look at page 383, problem 10.8. This is the last one before your homework. The measure of one angle formed by two intersecting lines is 3 times the measure of another angle formed by the lines. In this problem, we find the measures of the angles formed by the lines. Part A, draw a diagram for the problem. Okay, so we're going to draw 2 intersecting lines, and we're going to try and make it so that roughly one of the angles is 3 times the other. So the first line, we're just going to keep it simple, nice horizontal line there. And I just need one of the angles to be quite a bit smaller than the other. So I'm going to do something like that. And so this will be my smaller angle, and then over here on the other side, that will be the larger angle. They didn't give us any variables, although you can see in part B they recommend the use of x. We're going to call this smaller angle x. Now, if we're following the directions, and that smaller angle is x, what can we go ahead and say about the larger angle? If you said, oh, well, it's equal to 3x, you would be absolutely correct. They said it was 3 times as large as the other angle. And then furthermore, what can we say about these 2 angles together? You might notice that blue line we started with was, of course, just a straight horizontal line, and that means that at this point, we are currently making a straight angle. And so one thing that we can say right now is that x and 3x must be supplements. X and 3x together must make up that 180 degrees of our straight angle. Now, of course, x and 3x we can combine to make 4x. Essentially, it's like we're saying we have 4 different parts to this system right now. Each one of those parts is some number of degrees, and the 4 parts together add up to 180 degrees. Or you might just think to yourself, well, this is an algebraic equation. We can simply solve this by dividing both sides by 4, and when you do that, you get that x is 45. So this must be a 45-degree angle. And on the other side, it would be 3 times as much. That is, it would be a 135-degree angle. Or if you didn't want to do 3 times 45, you could simply say, well, we know they're supplementary, so let's take our 180 degrees and subtract away the smaller 45-degree angle. And again, if you do that, you're going to get 135 degrees. Part C, find the measures of all the angles formed by the lines. Well, once you do your work on 10.6 and 10.7, hopefully this part will make a little bit more sense. But basically, you can figure out that this angle over here, the opposite angle, is going to have a measure of 45 degrees as well. And this angle down here will be 135. Good luck with the rest of your homework. I think it's problems 1 through 9 or something, beginning on page 391, continuing on to page 392. If you have any questions, be sure to ask me or Mrs. William.